Hello everyone, I am Minakshi working as an Assistant Professor IT Department KIET Group of Institution Ghaziabad. In this lecture, I will be discussing about minimum operation mode of 8086 microprocessor. So let's get started. 8086 microprocessor can operate in two modes. One is minimum, second is maximum. 8086 microprocessor has mode pin MN MX bar. So whenever we connect this pin to VCC or at logic high, then 8086 microprocessor works in minimum mode. So minimum mode operation is obtained by connecting the mode selection pin to VCC or logic high. And whenever we connect this pin to ground or logic 0, the maximum mode is selected. Logic at this mode selection pin will decide whether the 8086 microprocessor will work in minimum mode or maximum mode. Both modes enable different control structures for 8086 microprocessor. So whenever 8086 will work in minimum mode, it will generate control signal for memory and basic input-output interface. So in minimum mode, 8086 will work for operation of memory and input-output. Whenever maximum mode is selected, we'll define the coprocessor system, or we can say multiprocessor configuration system. So whenever maximum mode is selected, 8086 will work within coprocessor system. So minimum mode. In this lecture, we are going to discuss about minimum operating mode. So as we discussed, minimum mode is selected while applying logic 1 to the mode selection pin. And this is the single microprocessor configuration pin. And in this configuration, 8086 implements the memory and I/O interface. So this is a less cost-effective mode of operation of 8086, because in this mode 8086 works for basic memory and input-output operation. It provides all the control signals to implement memory and input-output interface. This is the pin diagram of 8086 microprocessor. It is suggested that before studying this lecture, you should go through the pin diagram lecture of 8086 microprocessor. 8086 provide address and data buses, non-maskable interrupt pin, general interrupt pin, clock, ground, power supply pin, address and data pin, address and status multiplex pins, bus high enable and status pin, mode selection pin, read pin, hold and HLDA DMA transfer pin, write control pin, memory input output operation pin, data receiving and data transmission pin, data enable pin, address latch enable pin, interrupt acknowledgement pin, test on wait pin, ready to synchronize slow devices pin, and reset the activity of processor pin, bus request and grant pin, bus priority lock pin, status pins for defining whether it's a memory operation, input output operation, interrupt acknowledgement pin operation, and instruction fetching operation, queue status pins. So in brief, we discussed about the working of pins. 8086 processor works in minimum mode and maximum mode. And some of the control signals are common to both the operating modes. So we have some control signal which are common to both the operating modes. And in these control signal, we have multiplexed address and data buses, address and status pins, minimum maximum mode selection pin, read pin, test, ready, reset, non-maskable interrupt pin, clock, and power supply pins. So these are the common signals to both the operating modes. Now we will see the minimum mode control signals. The signal which are generated by 8086 microprocessor when it works in minimum mode. So we have a list of control signals. As we discussed that minimum mode will be started by applying logic 1 or VCC at mode selection pin. And minimum mode signals have hold signal. Hold signal is for DMA request. HLDA, hold request acknowledgement. Processor acknowledges using this pin to the hold request. Write control pin. Memory and input output operation pin. Data transmission and receiving pin. Data enable. Address latch enable, which is used with the multiplex data and address buses. It denotes where that address is placed on the multiplexed buses. And INTA bar, interrupt acknowledgement pin. And this pin is used to acknowledge the interrupts arriving at INTR pin. So these signals, DMA transfer signal, memory input output control signal, data enabling and disabling signals, address latch enable signal, and interrupt acknowledgement signal. So in this minimum mode signals, we have memory as well as input output signals. So as we discussed, hold pin is used to get the DMA request. So whenever processor 8086 has DMA request, it will have at hold pin. After having the DMA request at hold pin, it will work as it does for DMA transfer. HLDA is hold acknowledgement pin. Processor will acknowledge through this pin after getting hold request. Memory and input output bar. This control signal will define whether the operation is for memory or the operation for input output. So this will pin select memory or input output. Write control signal. This signal will indicate whether the memory write operation or output write operation. Interrupt acknowledgement pin. This interrupt acknowledge pin is the response of the interrupt at INTR pin. So processor will acknowledge the interrupt using this pin. Address latch enable. Address latch enable shows that 8086 address or data multiplexed buses contains the address information. Multiplex buses are used to carry address as well as data bits. So ALE will define that these buses are carrying address bits. Data transmission and receiving. Whenever this pin will be at logic 1, it will define that data is being transmitted. And When it will have 0, it will define that the data is being received. So data transmit and receive signal shows that the microprocessor data bus is transmitting or receiving the data. Data bus enable activates external data bus buffer. It will show that the data buses has the valid data. These are the control signals which are being produced by 8086 microprocessor in minimum mode. This is the diagram for a minimum mode of 8086 microprocessor. Here we will have 8086 microprocessor. It will produce all the control signals for minimum mode as we discussed before. And here mode pin is connected to the VCC to define minimum mode. We have a clock generated which provides the clock input to the microprocessor for its working. And we have demultiplexer to generate the control signal for memory and input output read and write with the help of three signals: memory, input output bar, read and write. And these three signals will be converted into memory read, memory write, input read and input output write. As we discussed that the minimum mode is for memory and input output operations. So we will have two types of memory, RAM and ROM, connected to the 8086 microprocessor, as well as input output chip. Here address and data buses will be connected to these input output and memory. And we have discussed in the memory organization lecture that the memory is organized into two banks, even bank and odd bank. And we should have some mechanism to select even banks and odd banks. So we must have some chip selection logic which will select even and odd bank. So we will have chip selection even, chip selection odd for RAM, chip selection for even, chip selection for odd of ROM memory. And this selection will be driven by two pins, as we discussed in the lecture of memory organization. These two pins are BHE bar, bus high enable, and address pin A0. So these two pins will drive chip selection logic. And this chip selection logic will select even and odd banks of particular memory. As we have seen in the demultiplexing of data and address buses, 8086 has multiplex address and data buses. So it will have some address latch for demultiplexing of address buses. A latch is connected to the address bus for demultiplexing of address buses from the data buses. And here, after demultiplexing of data buses, a transceiver is connected. This will have the transmitter and receiver. This will have the buffers for data transmission and data receiving. And this transceiver will be directed by two pins. One is data enable. Data enable bar will define that the data on data bus is valid. So it will enable the buffers, data buffers, to accept the data from the data buses. And DTR bar pin, it will define the direction of the data, whether the processor is transmitting the data or receiving the data, whether the data on data bus is for transmitting or for receiving. So in this module, we will have 8086 microprocessor and a clock generator. We will have control signal generation logic, which will generate memory read, memory write, input output read, input output write from three signals: memory input out control signal, read signal, and write signal. And here we will have memory, RAM and ROM, and input output chip, because in minimum mode, basic memory and input output interface operations are done. And we will have a chip selection logic to select the even and odd banks of the memory. And next we will have demultiplex component of address and data buses. So in this component, we will have demultiplexing of addresses. So we will connect a address latch, which is driven by address latch enable signal. This signal will enable or disable this address latch. And here we will have transmitter and receiver, transceiver, and this module will be driven by two control signal. One is DTR bar and DEN bar. In this way, the minimum mode model is described. We can clearly see that 8086 microprocessor works with memory and input output to implement memory and input output operation in minimum mode. These are the references for this lecture. Thank you very much. Happy learning.